DQMH. Okay, DQMH is not for everyone, not for every solution. It's a very beautiful hammer that you can use to hammer lots of nails, but it's not the only thing.
I will agree with that.
All right, so if you want to start going to the slides.
Yeah.
Okay. Well, there's that's the feeler slides. I hope everyone is using their app. You can view your schedule there, find your session. Keep going. Next slide. Yeah. Okay. So I have the honor here of having Michael Howard presenting with me. He's pretty much going to be doing the whole presentation because this is his baby. My name is Fabiola de la Cueva. People call me Fab, as in fabulous and modest. Emphasis on the modest part. And I'm going to let Michael introduce himself in a minute. But can you keep going? This is the presentation you're in. I wanted to invite you. Yeah, this is definitely not the updated slides. But go to the next slide. There's a conference in the UK. It's called GDevCon. It's going to happen in August 21st and 22nd. You can go to gdevcon.com if you want to go there. The day before GDevCon, there's going to be a hands-on workshop that Steve Watts, George Hampel, and myself are going to do. It's probably going to have a big component on DQMH. The practical exercise is probably going to be done in DQMH. Whatever you learn there is going to apply to any modular application or framework that you're using. So if you're using Active Framework or anything else that library-based, it will work as well. That's
more than that?
Yeah. All right. This is something that started about a year ago. If you want to go find out more, there's the bit.ly for the Our Giants Are Female. There's a lot of women that are involved in engineering and in the story of science and technology. And sometimes we just don't realize that they're there. Like if you look at the solid, the L starts for Liskop, who is Barbara Liskop. So I want to make sure that there's opportunity on the presentations for people to highlight someone that's important in science and technology and in engineering. And I chose Christina Royers. She has been in NI Lab R&D since 1997. You pretty much use a feature that she did every day. She worked on the Getting Started window, the Options window, and all of that code is done in LabVIEW. So I thought it would be neat for you guys to know more about Christina. And Delacor, you probably already heard this before. We help teams focus on implementing good software engineering practices. We also help with hardware design. We have customers worldwide. We're a small company, but we are very nimble and flexible. And when we need to extend our team, we go and hire other people. We have several products on the Tools Network and some products that are not on the Tools Network but that we offer to our customers. The DQMH obviously is the one that everybody knows here. It won Product of the Year in 2016. But we also have all other products. If you want to find out more about DQMH, if you didn't know already, we have these sets of videos. We have a channel, a YouTube channel. It's called Delacor LLC, where you can find all the videos on DQMH and presentations. And the documentation for DQMH actually has embedded videos. So as you're going through the documentation, you can play some videos there. So what is DQMH? DQMH stands for Delacor Queue Message Handler. And it started because we wanted to help teams that have different levels of proficiency be able to work together. You want to make sure that when you're hiring someone out street, they just know enough LabVIEW to be dangerous, and you want them to be working and producing good code within 2 months. DQMH is a good way to get there. There's, if you go back, we wanted it to be accessible to NI support, accessible to CLADs, but we also wanted CLADs to be able to contribute to it. We wanted it to work with Teston. And one of the things is it uses LVOOP, but you don't need to understand it. However, I need to emphasize, if you do use OO, you can create your own DQMH template. So you can move the bar more towards OO if you want it. And it still use the same scripting tools that DQMH uses. We support multiple instances, which is one of the things that Michael really liked. And then we really focus on the developer experience. Anything that we do at Delacor with DQMH is thinking about the developer. We want you to smile when you're using DQMH, okay? We want to make sure that it's guiding you into doing good software engineering practices. And we do that with scripting. I mentioned that we are a small company. So what we have done is partner with other companies to create the DQMH Trusted Advisors Network. And we have Wiring Software is in Australia, StudioBots is in Canada, System Automation Solutions is in Denver, Test System Solutions is in New Jersey, and Hampel Software Engineering is in Germany. So if you are going with DQMH, you're not just going with this small company based in Austin, Texas. There are other companies around the world that can help you. And hopefully this network is going to be growing. There's also a forum online to work. If you have any questions, it used to be that it was mostly me answering questions. If you go to the forum now, there's other people answering questions as well. Okay, so I think that was it for me. There's going to be a couple of other filler slides at the end, and that's going to be it. So.
Well, currently I work for Advanced Bionics. What we do is we make cochlear implants. We're one of the leading cochlear implant makers in the world. What we do, that device actually restores the hearing to people who have actually lost their hearing. It's called a bionic ear. So, yeah, you can imagine my surprise when I found this company. I was like, wow. I remember $6 Million Man when I was a kid, so I thought this was incredible. What they do, we are extremely committed to our patients and making sure they get the best experience with our product. What this presentation is about is simplifying your HAL with LabVIEW, object-oriented programming, and DQMH. And what we are doing here is, notice it says how to cure your halitosis. Well, there's an article I read a few years ago that talked about poor HALs. And he said that how to cure your halitosis. That was probably my first introduction to HALs. So I was really interested in this, and I started looking more and more into this stuff. So here, there's the bit.ly for an article that I wrote, or a blog post that I wrote for DQMH, Delacor's DQMH, which explains in more detail how to do what we're talking about here. How we arrived at this. So my experience when I first started in LabVIEW, it was in 6i, and I remember the first time I asked a guy, we were using a flow meter, and said, hey, you use that flow meter, you wrote something from that flow meter, can I use that? He goes, sure. And I looked at it and everything was just wires, and I just go, I'll just have to write this from scratch. And so I noticed everywhere I went, it seemed to be the same thing. I even actually worked for an alliance member, and the only thing I saw was you had to be a fast coder, and I was never a fast coder. So that kind of bothered me. I was always looking for something to resolve that issue. And so the first introduction I saw was Goop. That was provided by Indivo. That was years ago.
Then Symbio, and now it's the GDS toolkit that NI took, and it's available on the Tools Network.
And I still use that today. And but it gave me an introduction to object-oriented programming in LabVIEW. And it also was, but the problem was extension was a little bit cumbersome. I still could extend it, but it wasn't easily achieved. So then LabVIEW object-oriented program came along. I liked it because now it was native to the system and it didn't have that overhead any longer. And then I found the factory pattern, and I was like, ooh, wow, this is what I need. And so then the active framework came along. And at this time, I added another engineer to the group, and this guy was actually a software engineer. So he grasped this concept like gangbusters, while the rest of us were running around like a bunch of blind mice. And so he loved it. I liked it because it did exactly what I wanted to do. It was easy to extend, but that learning curve was a monster. So one day, this article popped up about Delacor and winning the developer,
the product of the year.
The product of the year. And I said, oh, what is this about? And I read it. And I go, oh, let me take a look. So I took it home for a weekend, played with it, did a few things, brought it back to the other architect, which was Luis. I said, what do you think of it? And he and I came up with the same thing. We said, yeah, this is like the active framework we liked, and we liked it. And so what we did, though, we handed it to another one of the developers, and we said, here, create something. He turned around and he did it quickly, and I said, okay, yeah, this is what we're going to use. And so, yeah, so these are all the things I read to come up with this concept and presented it to the group, and then we came up with this framework. So yes, and we believe we can do it after reading all these articles. So the team right now consists of 7 guys. 2 of us are working at a CLA level, that's Luis and myself, and then the rest are working as either CLDs or CLADs. Now, all of us have our CLADs, we just haven't had time to take our CLDs. What we had, and one of the inspiration was this homebrew test management architecture that we had. It was horrible, to say the least. And it made our test times extremely long, and it was very cumbersome for guys to actually implement any new testing. And oh yeah, by the way, it didn't fit in test stand at all. So we wanted to move away from that and move to test stand. And plus, and then throughout the company, we have people who use LabVIEW casually. So the concepts we're going to talk about. What is a hardware extraction layer? So Bloomy, which is one of the articles that I read, in their definitions, a hardware extraction layer, HAL, is a code interface, not a class interface, that allows application software to interact with hardware components at a general level rather than a direct device-specific level. The AT use case, which is what most of us are interested in. Hardware extraction allows code to be written using generic predefined functions independent of the specific hardware and other implementation. The goals and objections for HAL in our company. The HAL must-haves. It has to be reusable. And to do that, what we did was limit the functionality scope. So if it was a DMM, but it could do data acquisition, it's just going to be a DMM. So just because it had all those fancy functions on it, you didn't need them. So we limited that scope. We wanted to simplify the integration. We wanted to make it extendable and reduce the application development time. The must avoids, loading unused instrument classes, referencing specific instruments. So if an instrument had a specific feature, you did not want to reference that at all. Adding one-size-fit-all cluster, so you're, oh, well, let's squeeze it in because it works. No, that's why we limited the scope. And then magic delays. You should be able to switch out any device and not have to worry about the performance of the device affecting the performance of your test. Our implementation, now this is how we came about our HAL. So we created a class diagram. In this class diagram, you'll see the HAL utility, and that is our parent class, and all class devices inherit from this one. Then the device level is the device itself, DMM, oscilloscope, whatever we want to call it. And then there's the manufacturers, A, B, C, or D, and then we actually have the model. And the reason why we did this was because what we wanted to do is if there was something that was truly specific that was to that device, and a lot of times you'll notice that in the initialization, especially with Agilent, they were looking for a specific model in that, and you could either turn the query off or you can leave it on. But sometimes you couldn't turn the query off and it would throw an error. So this is that's why we did this, so you wouldn't have to worry about that. So this is a DMM class using that exact model. So here's our HAL utility. Here's the DMM parent class, and these are all the methods that can be called using this parent class. And you notice we have a file level, so we call it DMM class level 0, level 1, level 2. So on the level 0 is the parent class. Level 1 is the device manufacturer class. And then on level 2 is the actual instrument itself. So this is an example of us implementing a class, statically loading classes. This is our first attempt. When I looked at this, it had one major drawback. It loaded all the objects. Because as soon as you put one of those objects on the block diagram, it loads everything that's associated with it.
And the biggest problem there too is if you go to a test bench that doesn't
Doesn't have
have
it.
that code, then you start getting all sorts of errors.
You get errors. So, this problem, it works, there's pros to it, you know, the common interface for all the calls and access to multiple devices. That was nice. The cons was loading all the devices, requires a precise presence of all child components, and extending multiple devices was still cumbersome. So, this is what we use to resolve that. Selectively load instrument classes. This works well. Now, you notice what we have highlighted here is we're selecting the device and we have a path. Yeah, some people probably see this and they're going, yeah, we wouldn't do this. We don't do this either. This is just for demonstration purposes. It was just for a quick demo.
But they dynamically form the path. The
Path.
idea is that you're loading at runtime. Everybody sees that? Okay.
So, what we use is the factory pattern. And we use this factory pattern to actually load the class that we want at runtime. This is how we implement it. We have a method called getClassFromPath. What it does, in comes the selected path, out is casted that generic class that you see here, which is our parent class, is cast that specific class. So, now by using that, we only load what we selected. So, now looking at this, loading classes for unused instruments, the pros are common interface for calls, access to multiple devices, loads only the desired devices into memory. The cons, still extending it to multiple devices is cumbersome. So this problem we have to overcome now. So the cumbersome extension of multiple instruments. So solution one was the active framework. Very steep learning curve, as I mentioned before. Lead architect overload, answering a ton of questions. So that meant Luis and I would be constantly walking guys through this stuff.
The way I heard that story was that you really wanted to use DQMH and Luis was still kind of having, and then he said, which questions do you want to answer? The actor framework questions or the DQMH questions? Okay, DQMH it is.
Yeah, see, because he loved that because he was a software engineer. And the poor monitoring of actors, you know, so that was, and if you've ever used active framework, that was a nightmare.
Decoupling.
Yeah, and one of the things, it's gotten better because members of the community had created tools. So there's the actor monitor from MGI that you can use. Sam Taggart created API testers for actor framework, but back then, none of that was there.
Yeah, because we started this journey about 3 years ago. And so, solution two, Delacor queue message handling. It was easy to learn due to the queue message handling familiarity. Everybody in the group understood that. Plenty of documentation and demo support. The developer experience tools, all the scripting tools, made life a lot easier. And then the excellent test stand integration. That was one of the winner chicken dinners for me. It really was, because I knew we were moving to test stand, and I knew I heard another guy, he's in the room right now, screaming at the top of his lungs about certain things. And so this is why I was looking into this for that. And then the built-in debugging tools, which are the API tester that allows for verification of operations outside of the test stand environment. Because if anybody's written anything in test stand and you didn't use it as a test executive, you use it as your test development, you're going to pull your hair out. This keeps you from doing that. As you can tell, I pulled mine out. Easy to insert failure modes. So yeah, that was. So the cumbersome extension of multiple instruments. So the solution, we went with the Delacor queue message handling. So here we have highlighted the load class object and initialize the device. The clonal module performs all that heavy lifting that we would have to do to extend to another device.
This is the API tester, for those of you who are familiar with DQMH. So this gets scripted for you as you start adding new functionality and features to your DQMH module. It gets scripted for you. Of course, the decorations and the organization of the buttons is all the developer.
Right. So this is where we keep all our APIs for all our class methods. So if you look here, where's that? Below class object. Even if you look at this, it's in a specific order. Everything's on the left side. It has to do with starting up the system and getting it ready to run. Everything on the right side are just your API calls. So this is the load class object API call, calling a DMM class API. Because in actuality, our DQMH is a wrapper around our class, our DMM. This DMM DQMH is a wrapper around their DMM class itself. So here's the load class object from the DMM class. Here's our initialized device from the same class. And this is our DMMD DQMH API itself. So these that are highlighted are the core calls that are coming whenever you create a module, a DQMH module. These are the core calls you get. These are the ones that we add.
If you create your own DQMH template, you can change and modify how the show panel, show diagram, stop module work. An example of that is the MGI panel manager from MGI. That one uses classes underneath to replace the show panel. So it is possible to create your own templates and replace those functions.
So our DQMH, these are DQMH startup calls. Here's an example of a demo that we use where we're making those calls. The start mod and the sync events. So we're starting up two devices here. We're starting up a device 1 and device 2. So those are linked to that button. So when that button is called, this module is, this event gets fired. Well, there's an event that calls this. So then AB created DMM calls. So we have the load class object, initialized device, close devices. So here, once again, the load class, you have a button in load class objects because you can select which objects you want on that panel. Then the next one would be the configure. And the configure, what we're doing right here is just sending a configure API call. And so that method right there is actually calling a DMM method that configures the device. And then here we are, we're reading a measurement. When we pull that, we're actually reading the point off of device 2 using this call. Now you notice that here, we're actually using the mod ID for device 2 to make that call.
And you notice there's no class wires, right? Because all the class management is done directly inside the DQMH module. So a developer who has an entry-level developer and is used to doing train OBIs that get connected to each other, they can still do that, even though underneath the code you have the classes.
So here's our show panel. Stop. What we're going to highlight here is the stop module call. So notice here, I use a -1. By using that -1, I send a stop message to both devices simultaneously. So there's that extension that I was talking about. I don't have to work that hard to stop two devices and send messages to multiple devices. So here's the test and sequence using those same calls. Those are the DQMH startup calls and the DQMH stop module calls. And then these are the AB created calls. it simplifies the process. Now, what's nice about this, all the work is handled underneath, so there's no coding inside of this. This is being used as test stand was intended, as a test executive. So this is an example of how this will, oops, sorry, got started. Yeah. So this is one of our testers. As I explained to you before, this side right here has to do with initialization and startup of the DQMH and the devices. And all of ours have the similar interface. The UI includes all of the API calls. And if you make a call, if you have a new API, if you added a new method, you add a new call to this tester. So the calls to the left side, I've explained this. Part of this was, we did this because when a new guy came in, he had difficulties using these testers. So we had to make them all the same. So here we are, we're going to select a class. This one we're going to use the simulator. So we load it, and then the message says it loaded successfully. And that's something that we do, because we were doing this for debug, and it becomes part of all of our APIs now. So now right now we're going to initialize the device. It'll tell you whether or not it initialized or not. And so here's our panel. And what we're going to do here is actually change the configure measurement. So I'm going to send the message.
You were asking where Norm was? Norm is next
Don't.
door.
And so now we're going to do this with hardware. So in this, I'm going to have two DMMs, an Agilent 3401A and a 3410A. So we're
All the way from Los Angeles, you're going to see them in a minute.
so we're going to load the 10A class.
And there they are.
And so here, once we initialize the device, we put it in remote. So you'll actually see it go in the remote. And then we're going to do the second one, and we'll do the exact same thing. So here we select the device, because if you do it all, you'll get an error. We load the object. This was a GPIB device, so that's why it looks quite different than the USB device, the resource name. So now this guy goes in the remote mode. Now, here, we're going to change the resolution on both devices with a single call. And so, the decimal points changed when we did that. Now, what we're doing here is I have a power supply. I set one of the devices to read 3.3 volts and the other one to read 9 volts. So we're going to read the first device. It's going to read 3.3, then we're going to switch to the second device. And it's going to read 9 volts.
So he used the same API tester for 3 different devices, simulated, and 2 different Agilent boxes. Any questions so far?
Yeah, how many other instruments did you interact with?
Sorry, there's a question here first. What was that?
How many other instruments did you support?
So
Besides DMM, do you have other classes?
So
the power supply.
the question he asked is how many instruments that we create these APIs for. I think that's what you're asking.
Yeah.
So we have, in our company, we use DMMs, spectrum analyzers, stepper motors, power supplies, signal generators, spectrum analyzers, I just say spectrum analyzer, right? And we have network analyzers, SMUs, and so we have classes for all those.
Okay.
And even, so for every device that we get, if it doesn't fall into that class, we create a new HAL for it. If it doesn't fall under that, so we'll create a new one.
What was the question back there?
Have you evaluated the adoption of IBI at the beginning?
The question was if you have evaluated the use of IVI from the beginning.
No,
No.
I did not. Actually, I wasn't even familiar with it, so didn't cross my mind.
What is the advantage of this?
The advantage of this over IVI is that IVI was a lovely dream that did not get fulfilled. And not all the companies were implemented all the functions as the same, and you ended up having to write your own drivers anyway. So I think and you still have those issues here. One of the advantages of using the DQMH is that if you have a specific need for a specific device, you can add some code on the case structure inside the DQMH to take care of that, and it's still transparent at this level. Now, if you guys enjoy the presentation and want to hear from Michael again, make sure you vote for you give good kudos to this presentation, because he's not going to have time to talk about the measurement abstraction layer of this, which answers that question. But he can come next year and present about that. There you go, please.
How do you prevent those magic delays?
Well,
Every device, when you do a device reset or whatever.
well, if you realize you're going to be doing a device reset, that's going to be handled in your measurement extraction layer, not at your hardware extraction layer.
The magic delays is when you say, I put 5 seconds because I think that's what I need for the DMM to heat up, instead of going to the data sheet and reading what the data sheet says, that you need to wait until the DMM has heat up enough. That's the difference between That's not magic. That's the difference between a magic delay and something where you put in your documentation, I'm waiting 30 seconds here because the data sheet says on page 32 that I need to make sure that it has been on for this time.
Pretty long variable name.
Yeah, there you go. Well, you put notes, comments.
Or other things we're missing is, if the response is not ready yet, and you just have to force the delay.
Yeah, this is the other example they're saying here is people tend to put magic delays because they say, well, if I wait about 4 seconds, I get the response, but if I wait 3 seconds, I don't. That's a magic delay.
And that's still handled in your measurement extraction layer. That's not handled in the HAL layer. The HAL layer is just that, to communicate with the hardware, and you're extracting it from the measurement.
And if there's any magic, and if there's any delay there, it has to be documented. Otherwise, it's a magic delay.
Right. You need to explain why you're doing it. So this right here, this is how we implemented our HAL using this architecture that you can find in how to mitigate hardware to obsolescence in the next generation test system, which is really it's a second part to the halitosis. So I read this document after watching that video, and I saw this, and I can be honest with you, it didn't click immediately. So this is how we implemented it using our HAL. So this instrument driver layer is our child classes, which we call plugins, right? You hear that term all the time, plugins, but now you'll see where they're actually being used. This DSSP level, which is called the device-specific software plugin, is actually our abstract parent class level. In the ASL, which is the application separation layer, that's the instrument DQMH API. This right here forms our HAL. This part, I said more abstraction, please, and the reason why, because when you start developing these things and then you want to place it in the test stand, you want your measurement to be the only thing you put in the test stand. You don't want your HAL in the test stand. So that's why we wanted more abstraction. And we use this architecture. We're inspired by this one. It's a little changed from this, but we're basically inspired by this one. And this one actually came out of maximizing AT hardware extraction with a test stand. And there's a document that I think this was written by Blooming. I'm pretty sure it is written by Blooming. And so we took this, and then we kind of expanded it and made it our own, but the genesis was this. So also, that wasn't just the only thing we needed. So when I started, I actually ran the systems test group. And the systems test group and the AT group, I noticed there was a lot of things that we shared, but we couldn't share. So And one of the things, and also what I noticed was every other software development group in our building had a process. We didn't. All of us were fly by the seat of our pants, writing code, and most of it was ugly. I can say my stuff that I thought was great. I look back at it 2 years later and go, what was I thinking? So I really wanted to fix that. And the way I stumbled onto Delacor for that was my manager was insistent on me getting someone in here to help us write code, and I was trying not to get someone in there to write code. So when I called her, I said, fine, I'll call them then, because what they have done says they're competent and I won't be upset. And so when I called her, she said, that's not what we do. We help people organize themselves and to develop code as a group. And I said, that's exactly what I want. So I called her and they performed an audit. Yeah, we failed with flying colors.
No, you didn't do that, Bob. They were already using source code control, so
I
didn't need any heads.
We had that going for us. That was it. We were working on our style guidelines at that time. So, but she came in and helped us with that. We never used the VI analyzer, and we didn't have code reviews. And that was the hugest. If there's anything that was worth that money was telling us to do this, because I'll give you a perfect example. I hired a guy who was a rookie, never touched LabVIEW, which was perfect, because now I can see where we're going with what we were trying to do. We went through all the code reviews, we went through his work, but he was also using the architecture that we created. And it reduced the bugs. His code quality was better than anything that any of us had produced before that. And his proficiency was up there with the rest of us because he didn't have to work as hard. So that guy, and then the other thing was, you got to really see, because I was a tech lead, and I put quotes around that, how many bugs that I had in my stuff. You know, you go into a code review, I literally went into a code review with a broken BI once. Could not believe I did that. I just changed something at the last minute, didn't realize it, and the guy goes, really? But the point was, by me going in the code review, we see the broken VI, we fixed it immediately, and then we went on about the rest of the code review. And then you get suggestions from other people who say, hey, you know, there's probably a better way to do that. So your code becomes much more efficient and it has less bugs. And like I said, onboarding the new guy was a lot easier because we had a process.
We had some pushback from some of the old timers, like, why am I going to run the analyzer right? And then they started going to the code reviews of the new guy, and he was putting them all to shame. So it was really interesting to see, because you see someone that is inexperienced, but is following the process. The other guys were like, okay, it's not that he's smarter than them, it's just he was following the process, so they were more inclined to actually follow. And this was something curious that happened. The audit was going to take a long time, and they were on a deadline. So we started implementing things at the same time as the audit was going. And I didn't know that the new guy was the last guy that I interviewed for the audit. I hung up with him and I called. I'm like, Michael, are you using this guy as your guinea pig? And he was like, how did you know? I'm like, because I'm asking him, do you guys do code reviews? Yes, we do code reviews. Do you guys use VI Analyzer? Of course we do. And he was saying that for him, all the right practices were already being implemented because they were trying them all with him, and he didn't know.
So, in conclusion, you know, the whole purpose of this was for non-programmers. I wanted to simplify the hardware experience for them. When you onboard somebody and they're new to LabVIEW and they want to talk to a device, that could be a daunting task. This took that took that process away from them, and it also reduced our cost for development because we shortened our development cycle. Now it took us a long time to make all those APIs. It did. It wasn't. There was some heavy lifting done up front, but the return on investment was much higher because everybody's using the exact same libraries. So if there is a bug and we fix that bug, it's fixed through everyone's code now. So so we all have the same common development practices. No guy doing something. You know, it's not one of these kids doing his own thing anymore. all of us doing the same thing. Now we no longer develop in silos, and there was an example where the new guy actually was working on something, but he was really busy, and they needed me to pick up some of the work from him. So I paused what I was doing, he handed it over, and it was seamless. There was no, well, what were you doing here? Why'd you do that? Because he's following the process. It's easier for everybody to handle the work, so if a guy goes out, someone else can actually pick up their code now. Because when guys left the company, it was painful. And then I cannot over-exaggerate, reduce the amount of development bugs. That was the biggest win for us. So.
Yeah, so there's, if you guys, have you heard about the NI Learning badges? Anybody? Yeah? There are 2 badges for frameworks, Actor Framework and DQMH. I was very pleased with that. It's kind of like, we have arrived, right? There's a lot of really decent frameworks. I'm looking at you because your framework is really good. There are a lot of decent frameworks out there. But the ones that have taken off are DQMH and Actor Framework. And to be honest, I don't think there's anything very particular excellent about DQMH on the architecture level. It's a simple queue message handler. It is all the developer experience tools that really make the difference. So if you want to get your badge, you're a millennial or a millennial wannabe and you want to have your badges, you can go online to ni.com badges and you can take the test for the DQMH test. And there's also, if you do the next slide, there's also one for object-oriented fundamentals, and there's another one for object-oriented programming. And then the other thing that I was going to mention is that NI is trying to gather information about how we use LabVIEW. If you use LabVIEW for your makers projects, they're trying to run a survey. So I'm going to write down while Michael is taking questions. I'll write down the URL so you can go and answer the survey. The first 200 surveys get, I think, $25.
Oh.
So, okay. What was that? On Amazon. Yeah. So I'm going to write that down while Michael is answering questions. Unless you want to search it.
So, any more questions?
What other training resources or tutorials you guys have?
So, for the DQMH, you can go to Delacor, it's YouTube channel, and there's lots of videos, and there's a message board that you can use also. For ours, that bit.ly will show you exactly how to make that DMM class, and actually build that whole structure using DQMH. And it's step by step. So, because one of the problems I found over the years, well, when reading all that documentation, always seemed like it had holes, and I was trying to fill it in. And I had a great deal of that done. And I always say Luis was the guy that fit in all the little pieces that I missed in the software. Because by trade, by education, I was an EE, I could program, but I was not a software engineer. So I had to learn things like the factory pattern. I learned object-oriented programming through Java, but I never really, and so that's why I was able to pick up the GOOP pretty easily. But so what I tried to do was make it where if somebody really wanted to use this, they could just go to that blog and follow the steps in the blog, and it'll walk you through it.
And now with this, and then promote this, all of this code, he's being really nice. He's sharing all this code on a repository in Bitbucket. So you can actually go and do that. And he did a tutorial too, step by step, on how he did it.
So how do we get access?
That's there. That's where you get that.
Okay, just
That.
wait. Don't.
Question with your API tester. If you have a bunch of instruments.
I can't see you. Oh, there you are.
With your API tester, if you have a bunch of instruments, any advice about keeping that clean, organizing it?
Out of the group, I'm probably the guy that makes them look the best. So what I normally do is, if it gets, I always try to organize them by their functionalities, right? So I'll either add tabs or I'll add windows and boxes, and and keep it clean that way. And I try to keep it small because even though the monitors get bigger, the test stations monitors aren't very large, right? So at least if I had to do something on one of those test stations, I wanted at least that test to be able to fit on the window. So those are the things I told the guys they have to, these are the guidelines. We said they have to be able to fit inside of that window. And they don't, and they need to be organized. And so there's a review on those too. And we'll kick those back, say, you need to clean that up, this, try doing this, because we don't want the user experience to be different from each HAL. Every time they use one of those API testers, they should look very similar to that.
So do you have, for your measurement abstraction layer, did you do the same kind of approach as you did with the hardware abstraction layer?
Yeah, we did something. It was.
Let me repeat the question. The question is,
sorry.
if for the measurement abstraction layer, if you did the same approach that you followed for
Right, so you
HAL.
have like a base class of
No.
a measurement, and then,
No, on the measurement extraction layer, because depending on the test system that you're making, they're different. So what we do is, a perfect example, we have multiple battery testers or battery chargers. So you make one MAL that can handle all of those measurements, because the measurements are still the same, right? You're going to either be measuring the current, measuring the voltage, looking at some LEDs. So all those measurements were still the same on the hardware extraction layer. The only thing that was different was how we're going to route to make that measurement, because you have a different PCBA that is made for that specific device. So everything else was done all the configuration management was done in the measurement extraction layer. But the measurement would still be the same. So if you say read LED 1, read LED 1 would have to have a different switching mechanism because the PCBA is different. So it would have a different routing, and then but the measurement would still be the same. He's still using the same exact light code.
But for the measurement abstraction layer, you're not using a whole.
No. Just
so
no
so
object.
you, for example, we got in DMM, you got measure current, measure volts, AC volts, DC volts. So you might have a DQMH module for each one of those.
No, so the question was if we had a DQMH module for each one of the measurements. The answer is no.
No. So if you read so when you go to the bit.ly, it'll explain to you why we did what we did for the DMM. So the question that you asked, that is actually configuration, right? So on that one panel where it said select for 6.5 to 3.5. Well, if you look, there's some devices don't measure 3.5, some or have 3.5 resolution, and some of them have 6.5. So what you have to do is say that selector selects all of them, but on your class level you say we don't support that.
Mhm.
And it'll explain it in there, and I walked you through that whole thing because that's the part about not making your house stink.
I just think of a measurement extraction layer as you got a measurement type, then you look in a folder, factory pattern, who do I have that can make that measurement?
So the question here is, you think about a measurement abstraction layer as where now the class represents the measurement instead of representing the devices, right? Like you have a class for measure voltage.
Or it might not even be, I just think of a measurement abstraction as I want to make this measurement, and then maybe inside of that measurement, you have it look in a folder, or so what devices can make this measurement.
So the definition of abstraction is removing the details out, right? An abstract, for example, for this presentation was a very short paragraph, and then the presentation is 45 minutes, right? The abstraction layer on the devices is we just declare what are the functions at the top, and then the implementation is done by classes.
Mm-hmm.
But an abstraction can also happen without it can be object-oriented design without actually having calling classes. That's more what they're doing at the measurement abstraction layer. And again, goes back to working with different levels of proficiency. The people that are implementing the measurements are not necessarily as proficient on classes as the ones that are implementing the devices.
That works. No, I mean, even if we chose object-oriented programming for our MAL, you still have the same thing that we're discussing, right? I'm not going to go and look for that in the MAL. The MAL is, we have a lookup table, and you'd say, and when we open up the config file, it'll tell you exactly how to configure the system.
Right.
That's what we're doing with our measurement of that abstraction there. So that's why I said it's what we do, because what you need might be different.
Mm-hmm.
So, but this gives you a place to start.
Any other questions? So the people that are not using DQMH, are you kind of like curious now after this? What was that? Yeah, sorry. DQMH is free, by the way. So you can get your money back if you don't like it.
So are you porting that over to NXG eventually?
The question is if Delacor is porting to NXG. The code, the DQMH, the code that you create with DQMH is completely LabVIEW. There's no password protectors or anything. You depend on queues and classes. That eventually will migrate seamlessly to NXG. We go back to the reason why people use DQMH, and that's the developer experience tools. Those use scripting, and the scripting is currently not supported by NXG. It's supported using C#. So if you guys want to pitch in and pay for a C# developer, we'll be happy to transfer the tools.
I thought that was in the roadmap, though.
It is in the roadmap, but it's not.
Right now.
It's not
Yeah,
soon
I'm not
enough.
asking if you're doing it.
No,
actually.
yeah, we're doing it. We're definitely doing it. Yeah, we use it for our own projects. We use it for working with contractors. Some of you that have to hire contractors on an hourly basis, and you're worried about how am I going to measure the quality of their work? DQMH has made that a lot easier for us because the area of code that we need to look at is very, very small. And we have all the analyzer tools to verify that they didn't mess up with anything else that had to do with DQMH. So it makes it a lot easier to hire 5 people, 10 people, depending on what you're working on, and have them work on different DQMH modules. So we definitely, we use it. So we're going to definitely upgrade it. But we have to wait until scripting is available.
I have one basic question. So DQMH, what's the basic difference between using a regular queue message handler? That's the fact that we
Okay, so the question is, what is the advantage of using a DQMH over a regular QMH? The D. It's all it is. No, the advantage is an NIQMH, and there's a good presentation, if I may say so myself, that is called The Decisions Behind the Design of DQMH, and I show the transition between NIQMH to DQMH. The main differences are the NIQMH, or the traditional QMH, uses queues to communicate between modules. For us, the queue is private. We actually have gotten feedback that it shouldn't be DQMH, it should be Delacor Event Message Handler, because we use events for the inter-process communication. Why do we use events for inter-process communication? It makes it so your modules, you can use them as a standalone module, and it still works. And you don't need to do any scaffolding around it to talk to it because it's depending on queues. Events, if an event is fired and there's nothing registered to listen to it, nothing happens. If a queue starts in queuing and there's nobody to queue in, you're in trouble. So that's why we went with events. The other thing is the NIQMH kind of guides you to share the queues among all the loops. We don't like that. If debugging and troubleshooting is a nightmare because you don't know who sent what. So by separating queue of being private and events being external, that means that when I'm troubleshooting a message, I know that if it made it to the message handler loop, it was fired internally. If it makes it to the event handler loop, it came from the outside world. So it guides you to troubleshooting and debugging. And then finally, my favorite thing, it's the API testers. We haven't figured out a way to package me into the computer so I can slap you and tell you that you have to test before you write something. So the next best thing is when you are creating new messages for communicating between modules, the first block diagram that's going to pop in front of you is the API tester. And now on the latest version, the 4.2, it's even going to have the button in there. The only thing you need to do is drag it to where you need it. and wire your inputs. So if you're not keeping your API testers up to date, I really don't know what you want from me. Like, we really made it a lot easier. And that encourages people to be thinking about testing before implementing the features, and testing them and running them as soon as they implement the feature. I think I covered the major things. Did I miss anything for those of you who are using it?
That was good for me.
Okay.
So you're saying you're using events to get information from inter-processes. So does that mean you're attaching data to those events as well?
Yeah, the question was that I said that I use events that we use events to communicate between processes. Does that mean that we attach data? Yes, we do. The way the scripting tools work is you say, I want to create a request. A request is something outside my DQMH module asking me to do something. So I select the type of event, I set its request, I give it a name, and then there's a window next to put the arguments in it. So I can put the arguments. The code scripts for me the type them. It scripts the creation of the event. It scripts the destruction of the event. It scripts a VI that's going to fire the event. And it even puts it on the API tester so I can test it. If I say I'm going to do a broadcast, the same process happens. I have my little window to put my arguments, and the scripting tools are going to create the type def of the argument, are going to create the event, and are going to create the VI that's going to fire the thing, and then the scripting tools are going to put it floating somewhere on my internal code, because we haven't figured out how to read lines. And then you just drag it to where you need it.
So you're using the term event in a generic sense, not necessarily a LabVIEW user event?
Yeah, it's a
LabVIEW
user event.
user event.
It's a dynamic.
Okay.
User events are the worst thing named in LabVIEW. A user event, it means a dynamic event
Right.
or a custom event. It's just, NI sees us as users of LabVIEW, although we are really LabVIEW programmers, but well, yeah. So when I say events, we are wrapping those events in VIs. And we call them an API because the developers that are calling your code, they never really see the events. The only reason they know they have events is because they have to register for the broadcast. But a lot of the APIs, you don't even need the broadcast. You don't even need to register for those events. Make sense? Other questions?
So there's a Delacor toolkit for VI.
Yeah.
What does that contain?
Yeah, so
DQMH or-
if you go to VIPM, VI Package Manager, and you do a search for DQMH, the Delacor Q message handler is going to show up. You click that, and that's going to install everything.
And what's all in the toolkit?
Yeah, so the toolkit has the scripting tools. It comes with examples. It comes with examples for test stand as well. It comes with 2 project templates. It comes with a project template that's very simple, that has just top-level application calling modules, and then it has the version using DQMH of the continuous measurement and logging example that normally ships with LabVIEW. So on the getting started, when you say create project, if you install the DQMH, you're going to have a CML DQMH. It's a continuous measurement and logging example. So you can see the differences between how it is implemented using an IQMH versus how it is implemented using the DQMH.
Is DQMH LabVIEW version specific?
No, we support 2014 and later. It's
So
just,
I can get 4.2 and still use it with 2014.
what was that?
I can get your DQMH 4.2 and still use it with.
Yeah, you can use DQMH 4.2 in 2014. The best experience starts in 2015. And the reason for that is there was a bug in 2014 that didn't let us do the whole wiring process for you. So what we would do is we would leave notes, hey, you have to wire these 2 things, because otherwise we would make a LabVIEW crash. And starting in 2015 and later, we do pretty much wire most of it for you. The code also, when you script a message, it creates the event case and the event handler. It adds the case structure. It adds the enqueue. It adds the what is it that you want to enqueue. It does all the bundling of your arguments. All of that gets automatic. Basically, what we want is we want the developer to focus on solving the problem at hand and not doing repetitive work. And everybody using more or less the same style. Okay?
Does DQMH support RT real time?
Does DQMH support real time? Yes, it does. And we even have one of the tools on the menu. If you go to Tools, Delacor, DQMH, we have an option for creating a real-time tester. The reason for that is user events do work on real time, but interaction with the user interface just does not work in real time. And the API tester is all based on you clicking buttons. So what we do is we take your API tester, analyze it, and transform it into the old way. Remember when we used to have to do array of booleans to figure out which one was the one that was pressed? Well, we do that conversion, so then you can use it in real time. Yeah.
That's what they
Yeah.
Oh, that's
Yeah, but that's
how they
it.
do it.
The only thing is the real-time tester, we recommend that you only use it for clonable modules. The reason for that is if you are using Linux real-time with user interface enabled, there is a bug on BI server that doesn't allow you run BIs by themselves. They have to be re-engined. So if you try to use the singleton, or if you try to use the clonable running as a singleton, it's not going to work because of that limitation. But that has to do with a bug on BI server. Okay? Any other questions?
So, I mean about this one, so the presentation said you looked at the actual framework first, and then you moved to the DQMH, so it was a simpler version of kind of hierarchical class implementation. But how is it, so I didn't get how DQMH has the classes or the actual framework type.
That's not what I said. What I was saying was we looked at
Let
the.
me repeat the question. So the question was like, I heard that you were going with actor framework and then you moved to DQMH because DQMH had a simpler hierarchical classes, and you wanted, but you didn't see any classes for DQMH.
No, actually, it wasn't because it removed all that. That's the reason why we used it. Because, like I said, when we looked at the active framework, there's only one guy that was moving through it like a hot knife through butter. The rest of us were kind of fumbling our way through it. So when I saw this, like I said, I took it home and I played with it. I just wanted to make sure before I presented it to the other guy, Luis. I wanted to present it to Luis to make sure I had a strong argument. And so when I brought it to him, and he played with it, he said, yeah, I like it. And he called it, we both said it was like the active framework. We called it the active framework light. Not because it was object-oriented. It was more or less, they kind of behaved the same way. Each module was an actor, so it still had the same concept, except it was using it had a different architecture underneath. So, and the architecture was the queued message handlers, which everybody was familiar with, and object-oriented programming, not everybody was that familiar with. So that's why we went that route.
They also produce code that other members of the company use that are not LVOOP programmers. So maybe someone in R&D just needs to run something really, really quickly, and they used to always create it quick and dirty. Now they only have to run the API tester. The other reason we call the API tester running documentation is if somebody figures out the sequence of buttons that they have to do, all they have to do is right-click, find terminal, and they know exactly what is the VI that they need to call to get the same behavior. So they can integrate it on their own code. Okay. Any other questions?
So what I've seen here is that we are using DQMH modules as an action engine to execute some operations over your hardware abstraction layer, right? From the test sequence.
So the question is that, are we using DQMH as an action engine to execute things going on the hardware abstraction layer, the classes?
Yes, kind of.
Well,
I don't know when you say action engine. It's
I would be careful with the
Yeah.
term action engine because that's a term that's loaded in the LVOOP community. You know functional global variables?
Yeah.
Yeah,
But it's like
but let me finish. So the while loop that has shift registers,
Yeah.
if you're doing more than get and set, that pattern is called an action engine. So that's why it's overloaded. But as far as saying, yes, it's a wrapper around the class. We could be calling directly the methods for the class.
So you're hiding like implementation details over this abstraction layer into the modules. Right?
Yes.
So what's the benefit of doing that instead of keeping those details right in the sequence and calling directly the hardware abstraction layer?
So the benefit for us was I was able to extend that without any effort. If I were to do it the way you suggested, which you can do, now I'd have to make a copy of that same exact code. It does the exact same thing. And I would have to have all those references to that code, and I have to keep track of that in my wiring diagram, which gets messy. Now, and then secondly, I planned on porting that into my test stand, right? So if I put that in the test stand, how do I go about doing that? Now I have to keep track of all those references to the classes, which I don't want to do, because once you start doing that, test stand.
It's getting better, test stand to dealing with classes going from step to step, but it's not.
It's not an ideal situation.
Yeah, I think they do dynamic dispatch now. But back when he was evaluating this, that was not an option. And it goes back to, you want test stand to just be doing a sequence of steps, maybe deciding if something pass and fail, and that's it. Anything that's programming, you do it in LabVIEW. The API testers that you saw, you can also run them on a sniffer mode. That means you're running on test stand your sequence, and you're running your API tester, and all those messages that he was seeing on the status, they see them on that BI while the test sequence is happening. All of that without coding anything. Like, that is automatically generated by the DQMH. That's the whole feature from the DQMH. So that's another thing. Debugging clonables, debugging reentrant BIs. Has anybody here debug reentrant BIs? Right? How do you, isn't it like a pain to find the block diagram of the one that is giving you trouble? Okay, the API tester, that array of IDs that he had there, you can say, I want to open the block diagram of the second device. And it will open the block diagram of the second device. So you can then go troubleshooting.
Remember, this is, like I said, what made me really say this is the wheel was it was clonable. Because I knew how much work it took to extend stuff, because I'd done it before, and I didn't like it. And so when I saw this, well, that's it.
Yeah, the methods that ship with the DQMH is show module panel, have module component, and then show block diagram for troubleshooting.
Right.
So I know this is curious because we use classes to abstract details, right? And you're supposed to be using OOP to do the abstraction. And now we're taking traditional LabVIEW and wrapping the abstraction, so we provide another level of abstraction. The difference is in what is it that we're abstracting. With classes, we're abstracting the fact that I can switch and have any device work the same. With the wrapper on DQMH, what I'm abstracting is the code complexity that might scare some of my developers. It's just a different goal. Does that answer your question?
It seems like you could have measurements at that level.
Yeah.
You could say, okay, I'm going to put my measurement at the DQMH level, and that kind of is your measurement abstraction.
The other customers that I have, that's what they have done, is they create the measurement module or the test module, and then they have the DQMH through all the calls, and it's class-based. And this is what I was mentioning earlier. The reason I like when Michael suggested to present this is that because we say that you don't need to understand OO to use DQMH, there's a lot of people that say, oh, but I use OO, so I won't use DQMH. And that's not true. You can insert as much OOP as you want into the module, into the DQMH module. And you can create your own templates. So if there are things that you don't like about it, as long as you keep our scripting tags on the naming things, you're going to work. All right. Any other questions? No?
Yeah, how are you keeping track of the active modules that you're getting the VI name from property owner?
We are getting the clone name, the clone number. So we're using the clone number because we know that LabVIEW is already making sure that that's unique. All right, any other questions? Well, thank you. Oh, one more and that's it.
So on the receiving end of your messages, you have a LabVIEW event structure with a dynamic event. If it was queue-based and the receiving end doesn't take the message out of the queue, you've got the queue it's going to retain those messages. What happens with it when
an event structure is a queue?
Okay, so my experience has always been like if you're going to have an event structure, and you get an event, you want to handle that as quick as possible because you don't want your events to queue up.
That's why we relay it to the message handler. It's the way a main BI on DQMH looks like. It's two loops, an event handler, and a message
Okay,
handler.
so that was my question. So
The
you
queue.
immediately dispatch it
Yeah.
down to the,
To the
okay.
queue, yeah. And one thing that we recommend, and some of the other videos that I've done, is if you need priority messaging, you just create another loop with another event structure and decide what are the messages that you're going to be handling. I call them the chatty loops. When you have events that are firing too much and are going to prevent the other events from being handled, then you just relay them to a different loop. But yeah, that's why it's called DQMH, because inside the module, it is a queue message handler. The part that we miss with the name is the event communication between the modules. All right. Well, thank you very much. Enjoy the rest of the day.